Hi everyone. Today we are going to discuss about PN junction diode and its characteristics. The PN junction diode is the basic devices of electronic circuits. It plays a major role in the electronic circuits designing. Here it is two layer, two terminal and one junction device. The two layers are P and N. The two terminals are anode and cathode. The terminal which is very close to the P is called anode. The terminal which is very close to the N is called as cathode. The one junction, that is J. Generally, the diodes are made up of two semiconductor materials. One is the silicon, another one is the germanium. The breakdown voltage of the silicon is 0.7 voltage. Breakdown voltage of the germanium is 0.3 voltages. By cost wise, silicon material is very less than the germanium. That's why in the market, silicon based diodes are widely available. The symbol of diode is like this: the anode terminal and the cathode terminal. Why the symbol of diode is represented by an arrow mark, one straight line? Because the first diode is invented in the year of 1920s. At the time the vacuum diodes are invented. The vacuum diode, there are two electrodes, one filament. By heating this element, this electrode emits the electron, which is called as the cathode terminal. Then opposite terminal, which is anode, this electrode is collect the electrons from the cathode. So from this phenomenon, the symbol of diode is derived, which means there are two plates, two electrodes. The emitted electrons are consumed by the opposite electrode, which is namely anode, which is cathode. First two letters 1N, which means that is the one junction, 400 reverse blockable voltage, and it's able to carry 7 ampere. Diode, one white color band is indicated to refer the cathode terminal. So here see this is the device, diode. The white color band is indicated at the end of one terminal. It indicates the cathode terminal. Opposite of this band is anode terminal. It is works based on two modes. One is the forward bias, another one is reverse bias. Now we will discuss about the forward bias. So this is the forward bias structure. This is a DC voltage source. The positive terminal is connected with the anode of the diode and negative terminal is connected with cathode of the PN junction diode. And here in the positive plate, majority carriers are poles, which means that positively charged, and negative terminal is directly connected with the negative plate. In the negative plate, the majority carriers are electrons, which means that negatively charged particles. So here the positive plate is already having the poles are having, so therefore the positively charged particles here. The terminals of the voltage also is positive, therefore poles are same. Here the plate poles and terminal poles are here same. Due to the same poles, the junction is breakdown once the junction is breakdown means the electrons is automatically jump from negative plate to positive plate. Once it's jump from negative to positive plate, here one vacuum is created, which means that empty place is created. So due to the more pressure of positive plate, the holes are wanted to occupy the empty space of the negative plate. Therefore, here the holes are moved from positive to negative and negative plate. Similarly, all the electrons are moved from negative to positive and holes are moved from positive plate to negative plate. VI characteristics. The characteristics you may noted by the graph, or which means indicated by the graph. There are two axes. The x-axis is VAK, the y-axis is anode current IA, the origin point is 0. So initially here you have set 0 voltage, then you observe the current in the anode side. Definitely no current flows from the anode to cathode, because the minimum operating voltage of the diode is 0.7 voltage in case of silicon. Therefore, the junction does not allow the current from anode to cathode, so it maintains 0. Now you have to increase from 0 voltage to 0.1 voltage. That time, now you have to observe the current. Now also there is no current in the anode. Up to 0.6 voltage, no current flows in the anode side, because the minimum voltage for operating the junction or breaking the junction is 0.7 voltage. Up to the 0.7 voltage, junction does not allow the current from anode to cathode. So this is 0.1. Similarly, 0.6 voltage, no current flowing. Once it goes beyond the 0.6 voltage, slowly the current starts flow from anode to cathode, because the junction, the strength of the junction goes weakened slowly. Then the current starts slowly increase. Then once it crosses 0.7 voltage, the junction is breakdown. Once the junction breakdown, the current flows from anode to cathode. Then after the 0.6, 0.7 voltage, the current will increase linearly. The voltage is remain constant, the current only increase. Now if you draw the characteristics like this. So this point is called as forward breakdown voltage. Forward breakdown voltage, otherwise knee voltage. So this is the functional arrangements of the reverse bias. The variable DC source is connected across the diode, but negative terminal is connected with the anode of the diode. The positive terminal of the source is connected with the cathode of the diode. So here already I have said that there are the positive charged ions are in the positive plate, negatively charged ions, which means electrons, are in the negative plate. So here the positive charged ions of the P plate is attracted by the negative of the DC source. Therefore, the holes are moves away from the junction, which means moving towards the terminal. Similarly, the negative charged ions, which means the electrons are attracted by the positive charge, therefore the electrons are move away from the junction, which means it moves towards the DC source. So once it moves the DC source, the depletion layer of the diode is wildly increased. So depletion layer of the diode is wildly increased. This is called as barrier potential. This is called as barrier potential. So here no current flow. Now in this case no current flows from anode to cathode. Junction fully blocks the current in the device. Therefore here no anode current present in the diode. So far we have seen about the PN junction diode operation, construction detail and characteristics. So here the PN junction diode is widely used in the power conversion areas. The applications of the PN junction diodes are rectifiers. Mainly it is used in rectifiers, which means that it is used to convert from AC source into DC source. For example, adapter, the cell phone charger, inside the cell phone charger diode only is there. So thank you.